Chapter 9, Creating Machine Learning Application. Central Idea. Introduction. Creating Projects in Lobe. Introduction. Machine learning is software that learns to perform a task from a collection of examples rather than through a person explicitly defining rules and formulas. This learning software is called a model. Teaching a model through examples is called training. Image classification is categorizing an image into a single label to represent its content. In this chapter, we are going to learn how to create a machine learning application without coding. Lobe is a free desktop application for Windows and Mac OS that lets people with no programming or data science experience conduct experiments in artificial intelligence. Currently, Lobe learns to look at images using image classification, categorizing an image into a single label overall. It also allows developers to add machine learning capabilities to their own apps. Machine learning is everywhere these days, from spam filtering and facial recognition to voice assistants and driverless cars. But you don't need a master's degree to learn how to use this exciting technology, thanks to a new app from Microsoft called Lobe. You will learn how Lobe works and how to get started with this smart new tool. Here's how to create a machine learning model using Lobe's image classification feature. Steps to download and install Lobe in the computer. 1. Download and install Microsoft Lobe from the https://lobe.ai website. 2. Enter the details in the following manner and click Download. After clicking on Download, you will see the setup file gets downloaded. Click on the setup file and perform the following steps. Click on Finish. Creating projects in Lobe. Step 1. Start Lobe from your computer. Step 2. Click on New Project in the bottom left corner of the home screen to start a new machine learning project. Step 3a. Enter a name for your project in the top left. For this project, enter the name Fruit Classification to classify fruit images. Step 3b. Click on Import button. It shows following 3 options. Import images from computer. Import images camera by capturing images with the webcam attached with the computer. Import a structured folder data set of images. For the current project, click on Data Set to import a structured folder of images. Note, labeling is assigning categories to your images to create examples that teach Lobe. These examples are commonly known as a data set. From this data set, Lobe will learn to automatically predict a label for a given image. Step 4. Click Choose Data Set and select the folder containing the images of different fruits. Labeling is the first step in creating a machine learning model. Take care that all the images should have been segregated in different labeled folders, as at this stage we are training our machine. That is, we are going to show different types of fruits, and when it is trained, we would test it by giving any unlabeled image of any fruit and check whether it is able to recognize it or not. You can see all the images have been saved in different folders. Now, you need to select the main folder that contains all these subfolders of fruits. Step 5. Click Select Folder to select the folder. Second step is training the machine. Step 6. Click Import to train the machine. Note, training is how your model learns to predict the correct labels from the examples. You can think of the examples as a collection of flashcards. During training, your model will continually look through the flashcards and try to find similar patterns that helps it guess the right. The machine will take some time to train itself. See, the labels are added to the picks. Now, at this position, training is done. Result of training show you which images the model is predicting correctly and incorrectly. Correct predictions have green labels and incorrect predictions have red labels. The width of the label bar represents how confident the model was in that prediction. Hovering over a predicted label will show the true label you gave that image. The more correct the predictions, the better the model is performing. You can view and sort your images in different ways to check whether your model is successfully learning all the labels with View, All Images Selected. Approximately how well it will work on new images with View, Test Images Selected. Learn more about test images. Which images and labels confuse your model by selecting your individual labels in the sidebar? So, our machine can 57% predict the images correctly. There are many misclassified images also. For example, lemons are classified as apple, oranges are classified as apple, and so on. This simple means the machine needs more training. You can go for further training your machine or move further and test the machine. The machine can be tested by clicking on play. For testing, the test images should not be labeled. Third step is testing the model. For testing, you need test images. Test images are a random subset of your examples that Loeb hides from your model during training. Loeb automatically splits your examples into two parts. Random 80% is used to train your model. Random 20% is held out and used to test your model. See the results on only your held out test images by selecting View, Test Images. If your overall performance on all images is very high and your performance with test images is lower, your model may be memorizing your examples instead of learning to generalize to unseen images. This is often called overfitting. To help prevent overfitting, you can collect more images overall so the training set includes more variations. Make sure your images do not look too similar to each other. Click Images and drag and drop the images already stored in your computer in center of the screen. If you have a webcam, you can use the webcam as a video feed to test your model on new images live. You can see the model correctly classifies the image as banana, so you can add it to the data set by clicking on the green tick. This image also, the model correctly classifies as orange, therefore you can add it to the data set by clicking on the green tick. Let us try to test our machine for few more images. This is misclassified, therefore we need to assign it a correct label. In such situation, you need to click on the red cross. Here, we cannot assign the image to correct category as label orange is not there. Therefore, leave this image and do not add it to the dataset. Now, if you see the model is 98% accurate and 98% times, it is correctly predicting the fruits. Fourth step is to export the model so that it can be added in any app. Select Export from the hamburger menu at the top left corner. Select TensorFlow so that you can test this model using Python. You can export data sets in the following ways: as TensorFlow Lite for use in Android and Internet of Things app, as Core ML to develop iOS, iPad and macOS apps, as TensorFlow for use in applications coded in the Python language, Onyx for cross-platform apps, or local API to host the model locally. The model that would be created is a collection of files that other programs can load to run predictions. These files store both the structure of your model and the weights that are a result of training. You can use the model files locally in your app or in most major cloud platforms to create an API. Lobe also hosts your model as a local API to start app development. Create a folder to export the TensorFlow model and click Export. A model is a piece of code. You can export your model into a variety of industry standard formats to run on Mac and Windows, the web, or mobile and edge devices. You can click Optimize and Export or Export. Optimize and Export would take more time. Let us select Export and check how the model is saved. Click on OK. Open the folder where TensorFlow model was exported. Open the example folder and read the requirements and README file. This folder also has a Python program that we can test. Go to CMD or the command prompt window and install the TensorFlow by the following command: pip install TensorFlow. It would take some time to install the TensorFlow library. Then install Pillow by the following command: pip install Pillow. Now run the program from the command prompt. Go to the folder or drive where you have saved the folder generated by the Lobe. You can save it in any root drive so that it is easy to run the program. Also note the path of the test images as should be sent as argument. Let us now run the program. The model is predicting that the image that was supplied as an argument is banana. You can try predicting other images also and check if the model is correctly predicting or not. So, you are now able to create machine learning models and even add it to your programs.